All right, folks, I got a lot of things to teach you this week on the sine waves, cosine waves, and tangent waves. This is going to be kind of a basic introduction, couple things. You'll learn a lot more when you get into trig class. So all of this is based on a circle, and in a minute I'm going to show you kind of an animation that shows you this kind of shape that it creates. So the first function we're going to deal with is the sine wave. Okay, and whoa, that's not it. This is your basic sine wave, all right? And yes, it does go on forever, never stops at all. Okay, but everything is based on, why? I'm just activating the circle. Why does it keep doing that? I don't know. But the second function that we'll be dealing with is not the sine function, but the cosine function, which, has some similar properties, that's for sure. And then the third function we'll be dealing with looks nothing like those, although it is a combination of those, and that is the tangents. Okay, and the tangents kind of look weird, and if I back out, you'll see that they don't ever connect to each other or anything like that. They're all separate, and I'll talk more about that later. Now, let's go to the animation. So here we're going to be tracing out the sine wave while watching the y value. Sine goes with the y value. Cosine goes with the x value. Tangent goes with the slope. But we're going to see, particular video, that it's going to start tracing the y values here in a second. You see that as it's going up, the y values of the triangle are following, and we're creating that red sine wave. Okay, so that's pretty. Sorry, I had some problems there. But anyway, it'll continue to do this shape over and over and over again as you go around the circle. That's all I wanted to show you about with the animation. Okay, and that's what's creating this wave. Circular motion is being changed into linear motion. That's the important part of this, which obviously you'll see a lot more in the future if you take pre-calc and trig, mainly the trig portion. Okay, back to our Math Excel. Actually, a couple things I wanted to mention before we get to that are why isn't it? Let me see. Right, okay, so this thing down the middle, this is called the center line of the wave, and we measure some things there from that, such as the distance from the center line to the top or the center line to the bottom. That's called the amplitude. So the distance from the center line to the top and the center line to the bottom, each of those is called the amplitude. It's not the combination of the two. It's either one. So you don't have to measure it twice. You only have to measure it once. Anyway, the what we call the period of the function is the length that it takes to complete one cycle. Now, you can start anywhere you want. So, for instance, let's say you start here at 0, 0. It would be back at that same spot, starting over again, after 2 pi units. Actually, I should just kind of briefly tell you that the sine has an amplitude of 1 and then a period of 2 pi. Those are the normal, regular period and amplitude. So do you have to measure from that place to that place, or could you measure from the top of one wave to the top of another wave? Whoa, hit the side accidentally. Yeah, you could do that. Or you could go from trough to trough, or wherever it is easier for you to figure out what the period is. As long as you're starting in a spot and coming back to that same spot on the next wave. Anyway, let's get into the Math Excel. So in this first particular, section 1 of week 14, Swyk number 1, I start off with asking you a simple question. What's the amplitude? All right? And you could take a look at the graph. You could tell, okay, it goes from the center line. Center line happens to be at a -2, and it goes up to a +2. So that's a distance of 4. That's the answer to the question. Now you might look at this and go, well, what's the period of the function? Well, look at it. It's really not nice. And so that's why this question doesn't ask you about the period, because it's really hard to tell. So that's the answer to the question, just a plain old amplitude question of 4. All right, so the next question asks you about the period. All right, so you're taking a look at the graph, and you're trying to find spots that are easier for you to tell. Obviously, if you try from this location to this location, it's not so easy to tell. How about from trough to trough? Not so easy to tell. How about from the top of this hill to the top of that hill? Okay, that's easy to tell. It goes from 7 to 2. That's a difference of 5. So in this particular case, the period is 5. Now, a lot of times we're going to be dealing with, things involving pi, like radians, but this doesn't involve radians. The x-axis is based only on a count of like 1, 2, 3, 4, 5. So, I mean, those could be story problems that involve seconds of time or minutes or something like that. But nothing to do with pi. Next question, okay? So now we're going to get into a little bit more challenging stuff. Let's see here. I have in the upper right corner here written in a generic form of an equation, y over b equals sine of x over a. This is the beginning of something called Fireproof Form, which is a term that we at Homestead High School have kind of coined. You don't see it in textbooks anywhere, but it's just the beginnings of it. And if you have it in this form, in the correct form, or I should say in a particular form, it's easier to tell what's happening. What are the changes going on? So one of the things I want you to notice, or the amplitude is given to you as 3. That is the b value right there. And that's going to be in the denominator underneath the y. That is the vertical change. That's the multiplier on the y's. So we're basically saying that we're taking the graph and we're stretching it by 3. That means that it went from an amplitude of 1 to an amplitude of 3. Okay? So on my graph, I have to have something that has an amplitude of 3. This obviously couldn't be it because it only has an amplitude of 1. Now, the period has to be 6 pi. It has to complete one cycle. So one of the things that I didn't note earlier, but I should have, is that on a sine wave that has not been moved left and right, sine waves or up and down, it's only being stretched or shrunk in both the horizontal and vertical directions. 0, 0 is a great starting point. That's actually on the wave, on the center line, and sometimes I say on the way up the hill. Well, so the period, well, if the old period was 2 pi, then we can seriously look at what happens when you take a multiplier, we call it a, and we apply it to that period. So 2 pi times a. A could be a fraction, which means it's going to get smaller. Or a could be a number larger than 1, which means it's going to get bigger. Since the period is 6 pi, we can solve that equation by dividing by 2 pi, and we can find out that it got stretched by a factor of 3, which kind of makes sense because if the period was 6 pi, then you would be 3 times as big as you were before. And so you can see that I made sure that we had a period of 6 pi, and it went up 3 for the amplitude. That's letter choice B. These will go faster the more you practice them and the more you see them. This video might be a little longer, but I've only got 4 questions on here. Oops, sorry. So I put in my A and my B in my equation, and you'll notice that when the way they wrote their equation is different than the way I wrote my equation. So I would have to do a little bit of algebra to see what they are talking about. So for instance, I would multiply by 3 on both sides, and that would get rid of that, and that's why you see the 3 out in front of the sine function. They like to use theta here instead of x. I don't care. Whichever variable, whatever floats their sine wave. Now, instead of dividing by 3, they decided to say multiply by 1/3. Okay, division is the same as multiplication by the reciprocal. It's not that big of a deal, but that's the way they wrote it. So, same equation. All right, on to question 4. Similar type problem. They start off with an amplitude of 2, so there's your B value. Then we come in here and we take 8 pi is equal to, and we divide by 2 pi on both sides, and then you see that the A value is 4. So now we know what to put in here for A and for B. Okay, and we need something that has an amplitude of 2 in a period of 8 pi. You can see that we chose letter B. Now, what's the difference between A and B? Why is A wrong? Because A has an amplitude of 2, and it has a period of 8 pi. Well, the problem with letter A is that the B value is negative. The B value, if the B value is negative, it's going to cause it to flip over the x-axis. We will see problems like that, but that's why letter A is wrong. Now, how do I change the equation? Well, just multiply by 2 on both sides, right? Multiply by 2, and if we multiply by 2, we end up with their answer. Remember that x over 4 is the same thing as a quarter times. They're using theta again. Anyway, that's enough for the Swyk. See you in the next Swyk.